Hello folks, we're going to go over the 15s today. It's important that you pull out a highlighter and highlight some of the information as we're going along. I've got two jokes for you. Just watched a program about beavers. You finish the sentence. And two, why did the coffee file a police report? So there's a couple poems on this page. You should read those. It does contain some of the vital information that we're going to go over. It gives you a little bit of background information as well. So I'm going to read this to you, and you can read along, highlight some of the things that you didn't know. It says everything in the world is made up of atoms. Atoms are made up of even smaller parts called protons, neutrons, and electrons. So these three things right here make up atoms. These are also called subatomic particles, things that are smaller than an atom. They're smaller parts than protons, neutrons, and electrons, like quarks, also known as gluons, charms, strange, bottom, and top. We also have leptons, bosons, but we'll concentrate on protons, neutrons, and electrons. A chemical element is made up of one kind of atom. The atom is the smallest part of an element that has the properties of that element. So a bunch of gold atoms make up the element gold. But there will be one atom of gold, and that will be the smallest bit of that element. In other words, the element iron is made up of iron atoms. Elements can react together to form compounds. Iron, the symbol Fe, reacts with oxygen, symbol O, to form iron oxide. It gives you the two formulas. This compound has a common name of rust. Elements can also be mixed together to form mixtures and later separated back into those elements. So if you take two or more elements and you put them together, you get a compound, and that is the definition of a compound. Two or more elements chemically reacted. Or you could take some Au, which is gold, and you could take some Ag, which is silver, and throw them together, and you would get mixtures, kind of like coins in a bucket. A long time ago, the history was atoms are simply indivisible. Atoms were the smallest thing out there, and that's what Dalton said. Then Thomson came along, and he figured out that electrons are there. Electrons have a negative charge. We usually symbolize them with an E negative. Rutherford came along, and he noticed that the center of these atoms had a positive nucleus. And so the idea of protons started to come along. Bohr started to put the whole thing together with protons and neutrons in a nucleus with electrons moving around the outside. And he came up with several models. Even though that these models are not technically correct as what electrons do around the positive nucleus, it is still a model that we use today because it is simple to understand. The true model is quantum mechanics. And if you take AP, they'll talk more about that. So this Bohr model is the model that we currently use because it is the most useful and most understandable of all of the models. Are these real atoms? These pictures? The internet says yes, but as I tried to find out background information and supporting information as we're going along, I could not find multiple sources that will confirm it. So the internet says that we've seen real atoms. I still kind of think that we have not. That's how small atoms are. So my original joke was I just watched a program about beavers. It was the best damn program I've ever seen. So here I go. I'm going to read to you some more. Says the mass of an atom is extremely small. Therefore, subatomic particles must have masses that are even smaller. Since masses are so tiny, it is inconvenient to measure the masses in grams. Therefore, a new mass unit was created called the atomic mass unit, or AMU for short. An AMU is equivalent to the mass of 1/12 the mass of a carbon atom, whose mass is defined as 12 AMU. This makes one AMU a little larger than a proton and a little smaller than a neutron. The masses of the subatomic particles are. So these masses right here, we will never, ever ask you about. You just need to know that protons and neutrons have a large mass and electrons have an extremely small mass. For what we're going to use, we're going to say a proton has a mass of 1, the neutron has a mass of 1, and the electron has a mass of 0. The above masses are extremely small, but the proton and neutrons are 1,836 times heavier than the electron. In other words, I would need 1,836 electrons to equal the mass of one proton or one neutron. To calculate the mass of an atom, we say that the protons and neutrons have a mass of 1 AMU and electrons have a mass of 0 AMU. You're going to need your periodic table for the next slide. Protons and neutrons are found in the center of an atom called the nucleus. If you didn't know that, you should definitely highlight that. The protons have a positive charge and repel each other like two north ends of a magnet. So two north ends want to repel each other. A north and a south want to attract each other. To keep the nucleus from flying apart, the neutrons act like atomic glue and hold the nucleus together. So the purpose of neutrons is to hold those positive protons from flying apart. You might want to underline that particular sentence. Neutrons act like atomic glue. The electrons of an atom are negatively charged and move around the nucleus. If you didn't know that, you should highlight that. Electrons are negatively charged and move around the nucleus. The electrons are kept from flying into space by the attraction of the positively charged nucleus. So what we have is protons, which we represent with P's and a plus, and neutrons, which are neutral in charge. Those are in the nucleus. And the electrons are outside the nucleus, and they're attracted to that positive proton. The mass number of an atom is equal to the number of protons and neutrons in the atom. Remember, the electron has a mass of 0 AMU. So on your periodic table, if you look right here and you highlight this, mass number equals protons plus neutrons. It's never a decimal. You might get it confused with these numbers over here, and that is not what we're looking for in this particular unit. We'll talk about it in the next unit. So mass numbers equals protons plus neutrons because electrons, for all intents and purposes, have a mass of 0. The number of protons define which element a particular atom will be and is equal to the atomic number. So the atomic number is the number of protons. So this number right here always tells us the number of protons. Proton number and atomic number mean the exact same thing. All of the atoms of the same element have the same number of protons. If you change the protons, you change the element. Two different atoms of the same element can have different numbers of neutrons, though. These are called isotopes. So if you've ever known a set of identical twins, genetically, they are the same. Do they have the same mass? No. Those would be considered isotopes. So two atoms of the same element with different masses, those are called isotopes. Again, underline that if you did not know that. So here we go. For your first bit of work, you're going to use your periodic table. So if we look here, we see how many protons do we have? We have 4 protons. So write down 4. How many neutrons? 1, 2, 3, 4, 5, 6 protons. So again, the protons are the P pluses up there. The neutrons are the N's. What's the mass number? Well, we just learned on the previous slide, protons plus neutrons equals mass number. So we have a mass number of 10. What's the atomic number? We just learned on the previous page that proton number and atomic number are the exact same thing. So this would have atomic number 4. So if you go along on your periodic table, you should be able to find atomic number 4. So here we go. Here's our periodic table. This talks again about the atomic number and the proton number being the same thing. This talks about mass number equaling protons plus neutrons. So all of these highlighted ones, these are all number of protons as we're going along. And we can see this element has 1 proton, and this element has 2. And then we go 3 and 4 and 5 and 6, and they all have a different number of protons. So we're looking for, in this problem, something that has a proton number of 4 or an atomic number of 4, and that would be beryllium. There's a note right down here that says you cannot or can't add protons to an element under normal circumstances. In other words, never in a high school will we ever be able to add or remove protons from an element. Maybe some universities have fusion reactors and be able to do that. We do not. So under normal circumstances, you can never change the number of protons. If you add or remove protons, you change the element. So if I take zinc here and I add a proton to it, I now have gallium. It's no longer zinc. If I have zinc right here and I remove a proton, now I have copper. So in a normal classroom, you will never be able to add or remove protons. So there is your answer. We have beryllium as our answer. So what I'd like you to do is to do the next 3, and then I will reveal the answer. So pause the video, do the next 3, and then watch them and see if you did them correct. I'll show the second one at this time. Again, check your answers, pause the video, do the third one. Again, pause the video, do the fourth one. So there is your information. Always feel free to contact us if you're having some issues. On the bottom, it says boxes 3 and 4 are isotopes of the same element. So if we go down here, this one's neon and this one's neon. They both have 10 protons. That's what makes it neon. They both have an atomic number of 10. That's what makes it neon. But if we look right here, the mass number is different. Why is the mass number different? Because this one only has 11 neutrons and this one has 15. So these are the same element, but they have different masses because of different numbers of neutrons. So they're identical twins of each other, but they have different masses. All right, here it says, atoms are said to be neutral when the number of negatively charged electrons equal the number of positively charged protons. Using the information you have learned, fill in the table below for these neutral atoms. You're going to need your periodic table. So if we look at this one, this number 5, we have helium. That's element number 2. So that's up here in this corner. That's helium up there. It says that's atomic number 2. Atomic number and proton number are the same thing. So I put a 2 there. The mass number is 4. And we learned earlier that the mass number is equal to protons plus neutrons. So I have 2 protons. I don't know how many neutrons, but the whole thing has to add up to 4. So the number of neutrons must be 2. And we have 2 electrons and 2 protons because all of these are neutral, and that's what neutral means. The positive charges of the protons equal the negative charges of the electrons, and they cancel out. So why don't you go ahead and try zinc now, and I'll start to reveal some answers, and then do aluminum, sulfur, and so forth, and I will reveal the answers. Notice we're putting the words atom behind here because they are all neutral. So hopefully you did, in fact, pause the video and do the next ones. Here's the answer to number 6. If you haven't done number 7 yet, pause the video before I reveal the answers. There's number 7. Notice I'm putting the word atom behind it. That means it's neutral. Pause the video, do number 8. There's number 8. And pause the video and do number 9. If you do have questions, please contact us. So if we look here, it says the atoms in 7 and 9 would be known as isotopes. So again, same element, different mass number, because they have different numbers of neutrons. But if we do in fact look, 13 protons, 13 protons. That's what makes it the same element. So why don't you go ahead and answer the next couple questions before I reveal them. I guess that was all that we had on that page. All right, some more reading. It says molecules and chemical reactions happen due to atoms seeking stability. If an atom is able to have the same number of electrons as a noble gas, formerly known as inert gases, then it's stable. That's kind of a key point. You should highlight that. If an atom is able to get the same number of electrons as a noble gas, it's stable. Noble gases are the 6 elements in the far right-hand column of the periodic table. So pull out your periodic table, look at that. We got helium, neon, argon, krypton, xenon, and radon. The noble gases are so stable that they do not readily react with any other element. If an atom is able to gain or lose electrons so it has the same number of electrons as helium, neon, argon, krypton, xenon, or radon, it's got the electron number there, it will be very stable. When a neutral atom gains or loses an electron, it is now called an ion. In other words, an ion is a charged atom. Ions can have either a positive or negative charge depending on whether the atom gains electrons, becomes negative. And again, remember, electrons are negatively charged. So if you're gaining more negative charges, you become negative. Or loses electrons, loses negative charge, and therefore you become more positive. When an atom gains an electron, it is gaining a negative charge, so it becomes more negative. A neutral chlorine, Cl, has 17 electrons and 17 protons. If a chlorine atom gains an electron, so it has the same number of electrons as argon, 18 electrons, it now has the symbol Cl1- and will be called chlorine ion, or more correctly, chloride. Note all the ions of the nonmetals end in "ide," rather than calling them ion. For example, F1- is called fluoride instead of fluorine ion. O2- is called oxide instead of oxygen ion. When an atom loses an electron, it is losing negative charge, making the atom more positive. Neutral sodium has 11 electrons and 11 protons. It has the symbol Na. If a sodium atom loses 1 electron, it will have the same number of electrons as neon, 10. It now will have the same symbol it would now have the symbol Na1 positive and would be called sodium ion. For metals, we do not use the ending as we do with nonmetals. Using the above information, complete the table below for the ions listed. You will need your periodic table. So here we go. So bromide, we find bromide, and that is element 35. So find element 35. It's over here on the right-hand side of your periodic table. So bromide, that's a nonmetal ion. So it's going to be Br. And it tells us the charge right in the box. If you look in the upper right-hand corner of each of the boxes, it tells us the charge, 1-. I look at element 35, and if I look at the 35, what does that mean? I can go over here to the center, and I can look and say, oh, that's the atomic number. So what is the atomic number for bromide? It is 35. All elements that have 35 protons would be called bromine or bromide. It tells us the mass number. How many protons does it have? Well, the atomic number and the proton number are the exact same thing. So that's 35. Number of neutrons. Well, here I would take 80 minus 35, and that equals the number of neutrons. So at this point in time, why don't you pull out your calculator and make sure you have that ready to go as we're answering some of the questions. So the answer to that is 45. And how many electrons does it have? This is bromide with a 1 negative charge. So it's got 35 positive charges. How many negative charges would it have to have one more negative charge to give it a 1 negative overall? So here I would need 36. So 36 negative charges, which are our electrons, 35 positive charges, which are protons. So if you have negative 36 and positive 35, you get a 1 negative, and that's what the symbol is for bromide, 1 negative. Why don't you go ahead and try the N3 minus 1, and then I'll reveal some answers. So there again, that's number 1. Go ahead and pause the video if you have not done so and complete number 2. So in this one, we find nitrogen. And nitrogen is element number 7 on your periodic table. So we have N3 minus. We see there's a 3 minus in the box for nitrogen. So that's what the charge is always going to be, is a 3 negative. We add the ide. We drop the ogen part. So it's not nitrogenide, it's nitride. It's got 7 for an atomic number. So therefore, it would have to have 7 for a number of protons. We have a 3 negative charge, so we have to have 3 more electrons than protons. So 7 positives. What would it have to equal a negative 3? It would have to have a 10 negative, so it's got to have 10 electrons. Again, pause the video. If you have not done number 3, pause the video and then check your answers when you're done. So here we have magnesium ion. It's element number 12. So I find magnesium in the names. I see that it's got 12 protons. That's also going to be 12 protons and 12 for an atomic number. The ion, Mg, only has a 2 positive. So that means it's got to have 2 more positive charges than negative charges. So if it's got a 12 positive right there, sorry about that. It's got a 12 positive because of the protons, 12 positive. And it's got to have 2 positive overall. It must have 10 negative charges or 10 electrons. We add up the neutrons and the protons together, and that's how we get the mass number. Make sure you pause the video and complete number 4 before I reveal it. So here we have lithium ion. You might have heard of lithium ion batteries before. That's what we're talking about. So Li, 1 positive. It's not neutral, so that's why it's lithium ion. It has 3 for an atomic number, which is also meaning that it's got 3 for a proton number. So it's got 3 positive charges. How many negative charges must it have to have that 1 positive? Well, it must only have 2 negative charges. That's how I get my 1 positive. So that's what that 2 comes from. I have a mass number of 7. 3 of that comes from the protons. So it must have 4 neutrons. Again, pause the video and complete number 5 before you watch the answers. Iodide. That is element number 53. It's got 53 for an atomic number. It's got 53 for a number of protons. So it's got 53 protons. It's got 54 electrons. Protons are positive, electrons are negative. That's where that 1 negative comes from. But also, if you looked on your periodic table at element 53, you would see there's a 1 negative in the box as well. Protons plus neutrons equal the atomic number. So that's how we came up with that information. Try to answer the next batch of questions before I reveal the answers. So bromide has the same number of electrons as krypton. So if we look at krypton on our periodic table, it's got 36 electrons. And if we look at nitride, it's got the same number of electrons as neon, which is a noble gas. And if we look at magnesium ion, it's got the same number of electrons as a noble gas neon. And if we look at lithium ion, it's got the same number of electrons as helium. And if we look at iodide, it's got the same number of electrons as xenon. So again, elements on the periodic table try to get to the same number of electrons as a noble gas. So why did the coffee file a police report? It got mugged. I know they're bad jokes, but that's what I got. So the rest of this is homework for tomorrow. Thanks for watching.